All right, in this video, we are going to use the ratio test to determine if the series converges or if it diverges. And here's our series right here. Sigma n equals 1 to infinity, n to the fourth in the top, 2 to the n in the top, and then 5 to the n with a plus 3. This plus 3 is not up in there. These are two separate terms. So anytime we do the ratio test, we always set up a limit. L is equal to the limit as n goes to infinity of the absolute value of a sub n plus 1 over a sub n. Now, I always write that step because it will typically give me some points, whether it's on, a school test or whether it's on an AP test. Setting up that ratio is worth some points, knowing how to start the ratio test. So what I'm going to do now is figure out what a sub n is, and then also figure out what a sub n plus 1 is. Here's a sub n. I need to take all these pieces right here. So I just pretty much copy that for my a sub n. That gives me n to the fourth times 2 to the n all over 5 to the n plus my 3. Now, my a sub n plus 1, what I do is everywhere there's an n, there's 3 spots, I just replace it with an n plus 1. So let's go ahead and do that. That's equal to boink boink to the fourth with an n plus 1 times 2 to the n plus 1 all over 5 to the n plus 1 plus 3. So now what I need to do is divide them. So I get the limit as n approaches infinity, absolute value. A sub n plus 1 is going to give me n plus 1 to the fourth times 2 to the n plus 1 all over 5 to the n plus 1 plus 3. So all I did there was copy this because that's my a sub n plus 1. That's this right here. Now I need to divide, so I'm going to use that symbol. And then I'm going to write a sub n, I'm going to write a sub n, which is this thing right here. So this right here is just going to show up right there. So I wind up getting n to the fourth times 2 to the n all over 5 to the n with a plus 3. And then I close my absolute values. So you should be good at this step. We've done this lots. I need the copy dot flip to divide by a fraction. So I'm going to write my limit notation again as n goes to infinity, absolute value. I am going to copy all of this exactly as is. That's the copy in copy dot flip. N plus 1 times 2 to the n plus 1 all over 5 to the n plus 1 plus 3. And I'll bring my absolute value down a little bit there. Now dot is the dot. And then what I do is I flip this right here. So that's going to put the 5 to the n plus my 3 in the top. And then I'm going to divide by n to the fourth times 2 to the n and close my parentheses like that. All right, so what do we do from here? You could start canceling, but what I'm going to go ahead and do in this video is help you see, hopefully, how we reorder this thing. This is equal to the limit as n goes to infinity, absolute value. You should know that 5 times 4 is 20, which is the same as 4 times 5. I could also write 5 times 4 times 3. I could reorder that as 5 times 3 times 4. I can reorder multiplication and it won't change anything. What I'm going to do is reorder the multiplication in the top and reorder the multiplication in the bottom. One thing I want to point out is that these two have little parentheses around them. So if I move like this part of the top, I need to bring this with it. All right, so let's go ahead and do that. And I am going to color code this. And I'm going to order them in the order in which I think it's easiest to deal with them. So let's take the 2 pieces first. I get 2 to the n plus 1 over 2 to the n. That is this term. This term and this term. Next, I'm going to take these ones that I parenthesized in red. So I'm going to write 5 to the n plus 3 all over 5 to the n plus 1 plus 3. Now you may say, can these guys get combined here? And the answer is no. I got to leave them like that. Can the 1 and the 3 get combined? No. This is not up in that exponent. And now I'm going to write times what is left over. I have my, I missed something up there. Did you catch that? This should have a 4th power right there. Because, boink, I missed it right there. So that piece right there should carry there. So I'll continue in green. I get parentheses n plus 1 to the 4th all over n to the 4th. And then I'm going to go ahead and close my absolute value. So I'm going to erase this stuff. We talked about this a little bit in class, hopefully at some point, but if I have 3 to the 5th over 3 to the 6th, the easiest way to simplify that is to just cancel some things. 3 to the 6th what I'm left with is 1 over 3 because all of the 3's in the top cancel with all but one of the 3's in the bottom. If I had 3 to the, if I had 10 to the n plus 1 over 10 to the n, same thing would happen. That one, all the 10's in the bottom would cancel with all but 1 in the top because there's 1 more in the top, and that would just give me 10 over 1, or 10. So that's what we're going to do here. This is equal to the limit as n approaches infinity, absolute value. What I want you to see is that this 2 to the n cancels with all but one of those 2's up in the top. So that's the way I like to notate it. I like to cancel the 1 with the n all the way out, just like this, and then just cancel the exponents so that I can see that I have the 2. So I get a 2 times. All right, now in this next one, it's a little different because they don't directly cancel. But look, we've got a limit as n goes to infinity. So since I'm looking at the limit as n goes to infinity, you should be pretty used to saying, well, if I'm doing 5 to the infinity, or if I'm thinking about what 5 to the infinity would be, this plus 3 isn't going to matter. And same thing with this, 5 to the infinity plus 1, this plus 3 isn't going to matter. So what happens is I can ignore these two right here and just think about 5 to the n over 5 to the n plus 1 the same way we did with this one. What's that going to do? That's going to leave one of them in the bottom. All of these are going to cancel with all but one of those, and they're going to leave me with a times 1 over 5, very similarly to the previous one. So the last one is this one right here. So I'm going to talk about this a little bit. This one just gives us 1. You might see that. I'm going to give a short explanation as to why. So the limit, go to green. The limit as n goes to infinity of 4 times n to the 5th plus n over 3 times n to the 5th minus 2. So totally random problem, not related directly to this one right here. What I just want to say is that you learned a long time ago that if I have two polynomials, I'm trying to figure out what happens when they go to infinity. If they have the same degree, okay, this one would be 5th degree and this would be 5th degree, we don't need to think about any of these at all, and I can just take the coefficients. One way to sort of logically think about it is if I'm doing, if I'm doing 4 times n to, or infinity to the 5th, or if I'm thinking about 4 times infinity to the 5th, adding another infinity is going to be pretty inconsequential compared to doing infinity to the 5th. Think about, say I added 1,000. 4 times 1,000 to the 5th. That would be way bigger than this, and this would be pretty much inconsequential. We could say the same thing about the 2. So when we're thinking about infinities, we can sort of ignore those, and then what are we left with? I'm just left with an n to the 5th over the n to the 5th, and what happens to them? They cancel, and I'm just left with what? 4 over 3. So the process that you should have learned previously, or that you should understand now, is that when I have something like this, which we can sort of still see in green, I can just take the coefficients of the top and divide it by the coefficient of the bottom, as long as I take it with the highest degree that's there, and if they have the same degree. For example, if this was n to the 10th and n to the 5th, it wouldn't work. What I want you to see here is I've got an n to the 4th, and it's got a coefficient of 1. I have an n plus 1 raised to the 4th. If you think about FOILing this out and multiplying this out, this n to the fourth would be the leading coefficient or the highest coefficient of this thing. So because we're looking at the limit as n goes to infinity, this thing would just be we can think about it as a 1 divided by a 1, so that multiplies or simplifies down to 1. So what I want you to see here is we are almost done. Go down and give myself a little bit more space. This is equal to, well, I've got 2 times, limit as n goes to infinity of stuff, and there's no more n's in there. So I just get 2 times 1 over 5 times 1, which is just 2 over 5. And I'm almost done. My ratio test says that if the limit is less than 1, then this thing converges. If I get a limit bigger than 1, then it diverges. And this is 2/5. It's less than 1. So I just write less than 1, like that. And I write, therefore, the series converges by ratio test. Say, for example, instead of 2/5 here, I had gotten 5/2, then it would have been bigger than 1 and it would have diverged. Hopefully this helps you with the ratio test, and you can start doing some problems on your own. See you.